After the completion of project infrastructure in the previous video, we are going to implement the actual Cucumber. In this video, we will add and implement some steps to run the Cucumber project successfully. With the infrastructure in place and working, let's move on to actually implementing something Cucumber specific. Let us start with the first feature. Cucumber looks for files called feature in its class path. We must add at least one feature file for Cucumber to do anything. The feature file should be in the class path. This means that we should add in the resources folder in the Maven project. We will be using it for tests, so we will add a feature file in src/test/resources. Cucumber doesn't just look for features in its class path. It also looks for them in the same package or sub-package where the executing class is located. This means that we have to add the feature file inside the package called com.packedpub.mastering.selenium for it to be found. The name of the feature file is advanceddocumentation.feature. We should add something useful in it. What did we add here? We started out with adding a line that says features, and a sentence that describes what this feature is supposed to do. It is supposed to verify the documentation for the advanced features on Selenium HQ. A feature file must start with a feature. The description is arbitrary, and Cucumber will ignore it. It is only used for communication with other readers. In the next section, scenario is also arbitrary. I like the user story format, and especially the format proposed by Liz Kerf. So if you'd like to, put a user story here. It is optional, but I think it enhances the understanding and communication if it is there and says something useful. In this case, we'll try to describe the business value with Cucumber as a communication tool. The rest of the feature file describes one or many scenarios that are the actual steps that should be executed. The next three sections are really important ones: given, when, and then. Given describes the initial state where we will start our journey. When will be the step where we do something with the system under test. And then is finally the verification step. This is where we verify that the expected action actually occurred. The next thing we must do is to create some methods that can be executed for each step Cucumber finds. We could start with this directly, but there is a simpler way. We can run the build, and Cucumber will help us code snippets that can be used as a starting point for the implementation. After adding the feature file, let's run the project. Shift plus right mouse click on the project folder and execute the Maven clean test command. The build was successful, and it also gave us some snippets. Let's copy them and use them. Cucumber will search for the suitable steps in the current package and any sub-packages present. This means that we can hide the steps if we want to. I usually do that, so we will create a package that we will call steps and a class to hold the methods in that package. It doesn't matter what we call the class. Cucumber will search for the steps in all the classes it has access to. This implies that the steps are global. You may react with, global code, but why? The reason is simple. The features describe the expected behavior of the system. If you describe two different parts of the system with the exact same words, then you have a bigger problem than global steps. Cucumber will act as a whistleblower in that case, and you will be able to understand that you haven't defined the expected behavior in a unique way. Okay, let's create the package steps, and in it create the class Selenium Advanced Documentation Step Defs. This is so long that it almost looks like any enterprise system, but at the same time, it describes that this is the home for steps used to validate the advanced documentation for Selenium. And in the class, Let's import the missing necessary packages. Let's take a look at the code we just pasted into the steps class. In this class, there are 3 methods, and they are all annotated. This annotation is a regular expression that will act as the glue between Gherkin and Java. The regular expressions will be used to match the steps in Gherkin with the correct Java implementation. We have created the step definitions class, Selenium Advanced Documentation Step Defs, under the package com.packedpub.mastering.selenium steps, and created the step definitions skeleton by pasting the content. Now is the time to implement our Selenium Java code and verify the page title for the page Object Design Pattern. Actually, we are going to implement the page object pattern here. I have created 3 page objects under the package com.packedpub.mastering.selenium.pageObjects at src/main/java folder. There are 3 classes: Selenium HQ, Documentation, and Page Object Design Pattern. These will be used for navigating to the desired page. Let's briefly describe implementing given, when, and then steps. The given steps talks about seleniumhq.org being available. In this step, it will visit the seleniumhq.org and verify the correct page. The next step is the when step. This is where we actually do something with the system we want to test. The page object we created earlier is very handy to use now. Let's create one instance of the documentation for transiting to the page Object Design Pattern, and locate the title of the page objects. We should save the actual value in an instance variable and assert it later. The final step that we must implement is the then step. We are interested in getting the expected heading as a parameter to the method. The reason is that we want to allow someone to change the title on the target page, and the only update we should be forced to do is update the expected behavior that we defined in the scenario. This means that we have to capture the text from the then step. The way to do that in Cucumber is to use a group in the regular expression. We want to capture Test Design Considerations, Selenium Documentation. So, let me replace that part with a group that matches any strings, dot and asterisk. This will capture the expected title, and we can perform a validation using the same hamcrest matches as before. Let's run the build again, and we'll see that it passes. The build has been successful, and our Selenium Cucumber project was executed correctly as well. But did we actually execute the code we expected? Let's change the expected title in the feature and rerun. We'll type Mastering Selenium Testing Tools. That didn't go too well. We had a failure. But this is a good sign since we changed the expected title and the build failed. Pat yourself on the back. We've come a long way so far. There's so much that you've learned. Good work there. Now that we've seen the implementation of Cucumber in this video, let's look at the code organization in the next video.